Hello children, welcome to this NEET crash course. Today's chapter for discussion is Oscillations, Waves and Sound. We have already discussed the synopsis. We are familiar with the equations and concepts. Let's take up a couple of problems based on what we have learned. Example 1. Of the following, the potential energy of a particle executing SHM is given by. Simple question. Remember, the potential energy is of the form half k x square. So it must be basically a function of x square. It must be a function of x square, not involving any other terms. Remember, here this can also be of this form. X, remember, is measured from the mean position. That means position at which the value of force is 0, and x perhaps can be measured, or it is measured from the origin also. So x is perhaps displacement or distance measured from the origin also. So this can also be written as something like x minus some constant k into square, or say half k into x minus say another constant n or something like that. So x minus n whole square. So any function which is of x minus some constant square represents potential energy, and A is our correct choice. Remember, this function involves x, x cube, etc. So this can't be correct choice, and exponential function is obviously not a choice. Potential energy cannot be constant for a particle in SHM. Example 2. The displacement of a particle performing SHM is given by y is equal to 0.25 sine 200t centimeter. The maximum speed of the particle is, simple thing, maximum speed is given by a omega, and the value of a is given as 0.25 into omega is given as 200, and this becomes 50 centimeter per second. So maximum speed of the particle is 50 centimeter per second. C is the correct choice. Example 3. A particle is executing SHM with amplitude A and has maximum velocity v0. Its speed at displacement a by 2 will be. Okay. So notice that maximum speed is given as a omega, and that's given as v0. And we know that speed as a function of distance is given by omega root a square minus x square. So this is omega into root of a square minus half the amplitude a square divided by 4. Speed at a displacement, this one. So omega, this is 4 minus 1, 3. Thus I have a by 2 root 3. Or this omega a is nothing but v0. v0 into root 3 divided by 2 is the speed of the particle at half the amplitude. So v0 divided by 2 root 3 times. A is our correct choice. Example 4. A particle moves such that its acceleration a is given by a is equal to minus bx. The period of oscillation is, okay. Notice that the equation for the acceleration is equal to minus kx. This is our basic expression. And here he says a is equal to minus bx, right? So I can say k is equal to b. That means omega square is equal to b, right? So omega square is equal to b. Therefore, the time period, which is 2 pi divided by omega, is 2 pi divided by root b. So the time period of oscillation of the particle is 2 pi divided by root b. B is our correct choice. Example 5. For a particle executing SHM, the kinetic energy is k0. The maximum value of the potential energy is. Okay. Now the value of kinetic energy is k naught, he says. What does that mean? It means that the maximum kinetic energy of the particle is k naught. Now you know that the total kinetic energy, the total energy is constant. So we can say kinetic energy plus potential energy is constant. But when the kinetic energy becomes maximum, potential energy becomes minimum, generally 0. And that is equal to total energy. That's equal to total energy. When the kinetic energy becomes minimum, the potential energy becomes maximum, and that's equal to total energy. So clearly the kinetic energy and potential energy oscillate between their respective values, and thus the maximum value of potential energy is equal to maximum value of kinetic energy, which is nothing but k naught. So the answer is A. Example 6. A body executes SHM with an amplitude A. At what displacement from the mean position is the potential energy of the body 1/4 of its total energy? Okay. He says amplitude is A, potential energy is 1/4 of the total energy. You know, potential energy U is given by half m omega square x square. He says this is equal to 1/4 of total energy. Total energy is half m omega square a square. So if I consider these two equations, half m omega square cancels, leaving x square is equal to 1/4 a square, or x is equal to a divided by 2, which means the position at which the potential energy is 1/4 of the total energy is a by 2, not a, this is a by 2. B is our correct choice. Example 7. A particle performs SHM along a straight line with a period t and amplitude a. The mean velocity of the particle averaged over the time interval during which it travels a distance a by 2 starting from the extreme position is. Okay. So the construction is here. The time period is t and the amplitude is a. Particle starts from extreme position and it covers a distance a by 2. Right? So what's the displacement? Displacement of the particle is a by 2. Therefore, mean velocity is displacement divided by time taken. And what's the displacement? Displacement is a by 2. What's the time taken? The time taken to cover this distance is t by 6. You may wish to recall that the particle takes a time t by 6 to cover this journey of half the displacement starting from the extreme position. So this becomes 3a divided by t. Therefore, the average velocity of the particle is 3a divided by t. T is our correct choice. Example 8. The number of harmonic components in the oscillatory motion represented by y is equal to 4 cos square 2t sin 4t and their corresponding angular frequencies are. Okay. Now look at this equation. He says y is equal to 4 cos square 2t sin 4t. Let us simplify it further. 4 into this cos square 2t can be written as 1 plus cos 4t divided by 2 into sin 4t, of course. That is 2, these two cancel, 2 sin 4t plus 2 sin 4t cos 4t. So 2 sin 4t plus, if I simplify it further, this becomes sine 8t. Is that correct? You can check it for yourself. So if I expand sine 8t, I'll get 2 sine 40 cos 4t. So how many parts are there? This is like y1, this is like y2, and there are 2 components, and the frequencies are, for this one the frequency omega 1 is 4, and for the other omega 2 is 8. So 4 radian per second and 8 radian per second are the respective angular frequencies. So there are 2, 4 and 8 radian per second are the respective angular frequencies. Next one. A particle executes SHM. Its velocities are v1 and v2 at displacements x1 and x2 from mean position respectively. The frequency of oscillation is, okay, v1 x1, v2 x2 from the mean position. Something like this, x1 v1 and x2 v2. Now how do we relate them? You know that v is given by omega root a square minus x square. So v1 is equal to omega root a square minus x1 square, and v2 is equal to omega root a square minus x2 square. That is, v1 square is equal to omega a square minus x1 square, v2 square is equal to omega a square minus x2 square. I will subtract one from the other. I get v1 square minus v2 square is equal to omega square into x2 square minus x1 square. That's right, not omega square, omega. That's right, omega or omega square. So you can go back here, omega. V square is omega. So if I simplify it further, what do you get? This is v1 square omega, v1 square minus v2 square is equal to omega is 2 pi f into x2 square minus x1 square, or f is equal to, what is it going to be, 1 by 2 pi v1 square minus v2 square divided by x2 square minus x1 square. Right? Yes. Okay. Next one. A particle moving with SHM from an extremity of the path towards the center is observed to be at distances x1, x2 and x3 from the center at the ends of 3 successive seconds. The period of SHM is, okay. So now let us consider this. You know, it starts from extreme position. So the general equation is x is equal to a cos omega t. So I'll write x1 is equal to a cos omega, x2 is equal to a cos 2 omega, and x3 is equal to a cos 3 omega. Observe that the question says x1, x2 are measured, x1, x2, x3 are measured from the center. Now this is equation 1, equation 2 and equation 3. Let me consider equations 1 and 3, add them. x1 plus x3 is equal to a cos omega plus cos 3 omega, right? And I have x2 divided by x2, this should be equal to a cos 2 omega. that is 2 into 2, so cos 2 omega. And we can simplify it further. This gives me omega is equal to, or cos omega is equal to, x1 plus x2 divided by 2x2, or omega is equal to cos inverse x1 plus x2 divided by 2x2, or the time period is 2 pi divided by omega, that is cos inverse of x1 plus x2 divided by 2x2. 2 pi divided by cos inverse of x1 plus x3 divided by 2x2. So A is our correct choice. Couple of questions on waves and sound. The equation of a wave is represented by y is equal to 10 to the power of minus 4 sine 100 t minus x by 10 meters. The velocity of the wave is, okay. Y is equal to 10 to the power of minus 4 sine 100 t minus x by 10. So if we compare it with y is equal to a sine omega t minus kx, we get omega is equal to 100 and k is equal to 1 by 10. And we know that v is given by omega by k. So if I substitute here 100 divided by 1 by 10, and that becomes 1000 meter per second. Thus the speed of the wave, or the velocity of the wave, is 1000 meters per second. Example 12. A stone is dropped into a lake from a tower 500 meters high. The sound of the splash will be heard by the man approximately after. Okay. So we can show the construction here. The stone is dropped and it goes down, taking a time t1. Splash is produced. The sound takes time t2 to reach the person. t1 is the time taken by the stone to fall, right? That is given by square root of 2h divided by v. This is the time of free fall. t2 is the time taken by the sound to travel in a medium which is constant, so I can write it as h divided by v. Therefore the total time taken is t1 plus t2, which is square root of 2h divided by v plus h divided by v. With all the details here, this is square root of 2 into 500 divided by 10, acceleration due to gravity, that is g rather, my fault, 2h divided by g, plus square root of h, this is already done, so h is simply h, which is 500 divided by 330, and that adds to 10 plus 1.5, which is equal to 11.5 seconds. So the total time taken is 11.5 seconds. This is the time after which the splash will be heard by the person after dropping the stone. Example 13. The tension in a piano wire is 10 Newton. What should be the tension in the wire to produce a note of double the frequency? Okay. You know that the frequency is given by 1 by 2L square root of T by M, where M is the mass per unit length. This is applicable in the case of a stretched string. So notice that frequency is directly proportional to T. That's right. So F2 divided by F1 is equal to square root of T2 divided by T1. Or I will write F2 is equal to F1 into square root of T2 divided by T1. But he says F2 is equal to 2F. So 2f is equal to f into root of T2 divided by 10, or T2 is equal to 10 into 4, that is 40 Newton. So the tension required in the wire to produce a note of double the frequency is 40 Newton. C is the correct choice. Example 14. If equation of sound wave is given by y is equal to 0.0015 sine 62.4 x plus 3160, then its wavelength is. Let us compare this equation. Y is equal to 0.0015 sine 62.4 x plus 3160 with the standard equation y is equal to a sine omega t plus kx, or say kx plus omega t. What do we notice? We notice k is equal to 62.4. But you know, k is 2 pi by lambda, so 2 pi by lambda is 62.4. Or lambda is equal to, what is it? 2 pi divided by 62.4, and 2 into 3.14 divided by 62.4. So you can see this is approximately 20 times. So 1 by 20, or 1 by 10, 0.1 unit. Therefore, the wavelength is nearly 0.1 unit. Next one. The velocities of sound at the same temperature in two monatomic gases of densities ρ1 and ρ2 are V1 and V2 respectively. If ρ1 divided by ρ2 is 4, then the value of V1 divided by V2 is. You know that the speed of sound in a gaseous medium is given by root of gamma p divided by rho. That is, V is proportional to 1 by under root rho. Or V2 divided by V1 is equal to root of ρ1 divided by ρ2. But here we want the value of V1 divided by V2. So V1 by V2 is equal to root of ρ2 divided by ρ1. And he says ρ2 divided by ρ1 is 1 by 4. This is 1 by 2. So the ratio is 1 divided by 2. V1 divided by V2 is 1 divided by 2. Remember, it is V1 divided by V2, not V2 divided by V1. Next one. A vessel revolves in a circle with angular speed 20 radian per second using a string of length 50 centimeter. If the frequency of sound from the vessel is 385 Hz, what's the minimum frequency heard by an observer is far away from the center? Velocity of sound in air is 340 meter per second. Okay. So there is a source which revolves in a circle using a string of length 50 centimeter. And the minimum frequency heard by the observer. Okay. So here is the stationary observer and this is the construction. That's right. This is the construction. Now the vessel is moving along these directions. So the sound travels along this direction. Observe that the observer is far away, which means that for all practical purposes we can ignore the size of this circle. And you know that frequency is minimum when the source is moving away. That means corresponding to this situation we have minimum frequency. So it is like this. We have this observer and the source is moving away. And that corresponds to V divided by V plus Vs. Right? It is very simple now. And V is, what is the value of V? The speed of sound is 340 into, of course, f naught is there, my fault. F naught is 385 into V is 340 divided by 340 plus Vs. Speed of the source can be written as a omega. It is traveling in a circle where a is this distance, or r omega you can write. So this is nothing but half into omega is 20, therefore this is 10. So we have 340 plus 10, that is 385 into 340 divided by 350, and it simplifies to 374 hertz. So the minimum frequency recorded by the observer is 374 hertz. Example 17. An organ pipe enclosed at one end has fundamental frequency of 1500 Hz. The maximum number of overtones generated by this pipe which a normal person can hear is. So he is telling you maximum frequency must be 20,000 Hz. That's the audibility limit. And fundamental frequency is 1500 Hz. And it is closed at one end. That's right, it is closed at one end, it is open at the other end. And let n represent the overtone, then the frequency corresponding to nth overtone is given by 2n plus 1 into f. Right? So the maximum number of overtones is 2 into n, that is 20,000, is equal to 2 into n plus 1 into f, that is 1500, which gives us n is equal to 6. A is our correct choice. Next one. A closed organ pipe of length L and an open organ pipe contain gases of densities ρ1 and ρ2 respectively. The compressibility of gases are equal in both the pipes. Both the pipes are vibrating in their first overtone with same frequency. The length of the open pipe is. It's a closed organ pipe of length L and another open pipe contain gas of densities ρ1 and ρ2. Their compressibilities are equal. They are vibrating their first overtone with the same frequency. The length of the open pipe is. Here, the first overtone of closed organ pipe corresponds to 3f0 and the first overtone of open pipe corresponds to a frequency of 2f0. He says 3f0 is equal to 2f0. So 3 times V divided by frequency of sound in open pipe divided by 4L, right? Length of the open pipe is equal to 2 times. This is V0 divided by 2L. We can call it as closed pipe. This is VO open pipe and this is 3f0. This is closed pipe, so I will write as closed pipe and this is open pipe. So 3 times VC divided by 4LC is equal to 2 times VO divided by 2LO. The question is about the length of the open pipe. So this is 4 by 3 times speed of sound in open pipe, speed of sound in closed pipe into length of the closed pipe. This is our basic expression. That further becomes 4 by 3. You know, speed is inversely proportional to the density. So you can write this is square root of rho 1 divided by rho 2. Rho 1 divided by rho 2 into length of the closed pipe. So 4 by 3 L root of rho 1 divided by rho 2. This is the length of the open pipe. So length of the open pipe is equal to 4L divided by 3 root of rho 1 divided by rho 2. B is our correct choice. An open pipe is in resonance with second harmonic with frequency F1. Now one end of the tube is closed and the frequency is increased to F2 such that the resonance again occurs in nth harmonic. Choose the correct option. Now the second harmonic of open pipe is F1. So F1 is equal to 2 times V by 2L or V divided by L. Nth harmonic of closed pipe is F2. That is N times V by 4L is equal to F2. N is equal to 1, 3, 5, etc. Only odd harmonics are generated. So F2 is equal to N by 4 into V divided by L, that is F1. So N by 4 into F1, that is F2 is equal to N by 4 times F1. So as F2 is greater than F1, N should be greater than 1 and it should be odd also. So N should be greater than 4 and it should be an odd number. So the next best possibility becomes 5 divided by 4 times F1. So the correct option is N is equal to 5, right? Once you find the value of N is equal to 5, the value of F2 should be 5 by 4 F1. So B should be our correct choice. Next one. A source of sound S is moving with a velocity 50 meters per second towards a stationary observer. The observer measures the frequency of the source as 1000 Hz. What is the apparent frequency of the source when it is moving away from the observer after crossing him? The velocity of sound in the medium is 350 meters per second. Okay. This is the construction. Here is a stationary observer. Source is moving along this direction. And the observer measures the frequency as 1000 Hz. That means during its approach, the apparent frequency is F1. Now, he says, what is the apparent frequency when it is moving away from him? Okay. So clearly F1 is equal to F0 into V divided by V minus Vs. And F2 is equal to F0 V divided by V plus Vs as it is moving away. Right? So these are the apparent frequencies during approach and during recession. They move away, when it is moving away. Now the question is, what are the data we are given? We are given its velocity and the value of F1. And the velocity of sound in the medium is also given. So I will take the ratio f2 divided by f1 is equal to, what is f2 divided by f1? F naught into V divided by V plus Vs divided by F naught into V divided by V minus Vs. So F2 divided by F1 is equal to V and V cancel, leaving V minus Vs divided by V plus Vs. Or F2 is equal to F1 into V minus Vs divided by V plus Vs. Do we know the value of F1? Yes, that is 1000. V 350 minus 50 divided by 350 plus 50. And you can simplify it further. It gives us 750 Hertz. So 750 Hertz is the frequency of the sound recorded by the observer when the source moves away from him. With this problem, we have come to the end of this session. So practice all these problems one more time, get familiarized with these basic equations and learn the concepts clearly. All the best.